Hey guys, welcome to the NCEA Level 2 Calculus paper from 2018. So how this video works is basically the usual thing. I'm going to go through every single question here, tell you guys what you need to do for Achieve Merit and Excellence. What I would say for you guys is pause the video at the start of each question, try the question out by yourself just to see how you're going with it, and then just go through with my answers. Okay, so let's get started. First question is a nice and simple one here. We've got a function which is actually given by this f of x, and then we want to know, find the gradient of the graph of the function where x is equal to 4. So what they're actually asking for, and this is something that I always say to folks when they're doing calculus is, write down what you actually have. Okay, so in this case, you've actually got f of x, which is x cubed minus 6x plus 2, and then what you're looking for. So in this case, it's going to be f dash of 4. So let's differentiate the function. So when we differentiate the function, we're going to get 3x squared minus 6. And of course, we're looking for f dash of 4. So what's the gradient when x is equal to 4? So then I've got 3 times 4 squared minus 6. Whoa, what happened there? Sorry about that. We've got 3 times 16 minus 6, that's 48 minus 6, so you've got 42 as the gradient. Now, for achieved, as always, I have the look at the answer schedule right next to me. You've actually got to give derivative and the gradient found. So you need this part here, and you also need this part here. And I guess the reason you need both of those things is because you can get graphics calculators where you can actually work out the gradient by itself and not actually do any working, and I think that's what they're trying to avoid here. All right, let's go to question 1b. So what we have is we got a rectangle is expanding, so its length is 3 times its width. Find the rate of change with respect to its width when the area. Okay, what we're gonna do is we're gonna draw a little rectangle here, and what it says is that its length, all right, so that's going to be L. I'm going to put down as length is 3 times its width. Okay, so let's say I put down this as width, then the length is going to be 3 times its width, so that's going to be 3W. So that's the first thing we kind of need to do, like just kind of eliminate one of the variables. Because we know that area of a rectangle is length times width or base times height, however you want to do it. In this case, the length is equal to 3W because it's 3 width times the width multiplied by another W. So the area equation is going to equal 3W squared. But the question is actually asking, find the rate of change of the area of the rectangle with respect to its width. All right, so what you're actually looking for is, in this question, you're actually looking for d of A over dW. That's what you're looking for, because that area, rate of change of area, that's the dA, and then with respect to width means that's going to be at the bottom there with dW. But they give you one clue. They tell you that the area is 75 centimeters squared. So the first thing we got to try and figure out is, when the area is 75, what is the width? So we're going to do that first. So when the area is 75, what is its width? So when we do this, we're going to get 75 divided by 3, it's W squared. So we got 25 equals W squared. Therefore, we can say W is equal to square root of 25, or 5 in this case. All right. So when the area of this rectangle is 75 centimeters squared, the width is actually 5 centimeters. So that's the kind of like the first kind of clue that you need. The second thing is actually working out what dA dW is, and we're going to do that by actually using this equation here. So because we have A is equal to 3W squared, when we differentiate it with respect to W, we are going to get 6W. And now, because we've actually discovered what the W is, which is 5, we're going to replace it here with W itself. So we're going to get dA of dW is going to be 6 times 5, which equals to 30. Now, in terms of units, if you're like, oh, I got no idea what this units is, well, the easiest way to look at it is look at this particular, let me just show you guys in a different color here. So see this? That's area. So that means we actually write down centimeter squared at the top. And then the next thing is actually looking at the width, which is actually in centimeters. So we're going to write it like this. So what it actually is telling that it is actually, the area is increasing by 30 centimeters squared for every centimeter change when the area equals to 75. Okay. Now, in terms of units, there's no really any kind of indication about units, but what you can get achieved for is this thing right here gets you an achieved, and the rate of change, getting that gets you a merit. Okay, so next question. So what we have is an integration question by the looks of it, because we've been given the derivative. So what are some of the things you can actually do? So here we've actually got, let's actually look what are all the things we've got. We've got f dash of x, because that's the function. The second line there, it actually says the graph of the function has a local minimum, and I think this is really important. Local minimum at 0, 5. What that actually means is, first off, local minimum means f dash, so the gradient is equal to 0. Okay, because remember, when it's a local minimum or a maximum, the gradient is equal to 0. And in this case, the x value also happens to be 0. So that's what that thing right there is. But there's one more clue that's given to us, which is this point, 0, 5. So we can actually say f of 0 is actually equal to 5. So all I've done right now is I've just extracted all this information from those first two lines, and then I'm actually going to look at the question and see what the questions actually want. They use calculus to find the local maximum of the function. So I guess the first step I have to do is to try and figure out what the function is. Okay, so what I'm going to do is I'm going to write down f dash of x first. F dash of x is equal to minus 3x squared plus 12x. And when I integrate it, I'm going to get f of x equals negative 3x cubed over 3 plus 12x squared over 2. And then I've got, of course, plus c that I need to remember always. So simplifying this, I've got f of x is equal to negative x cubed plus 6x squared plus c. All right. Now I can figure out what c is because I know that f of 0 is equal to 5. I'm talking about this point right here. So I'm going to write down f of 0. Since f of 0 is equal to 5, I can rewrite this as 5 is equal to minus 0 cubed plus 6 times 0 squared plus c. And what ends up happening is 5 is equal to, well, I got 0, 0, 0 plus c is c. So the function itself, f of x, is equal to minus x cubed plus 6x squared plus 5. Okay? So that's the function. Now we're trying to figure out what the minimum and maximum is, right? So we can actually differentiate this function, which we kind of already know what it is, because when we differentiate this function, we're actually going to end up back at this point here, which is f dash of x. And so if we put f dash of x is equal to 0, so that's when it's going to be when it's minimum or maximum. All right. So then we've got minus 3x squared plus 12x is equal to 0. And because I can take the common factors of minus 3x out, what ends up happening is I get x minus 4 is equal to 0. Therefore, I can actually say x is equal to 0 or 4. All right. Now, we already know what 0 is because it's actually told us that this is the yellow point that we're talking about. That's a local minimum right there. So we already know that this x equals to 0 is when the minimum happens, which means when x equals to 4, the maximum should happen. But we need to actually figure out what it is. And so I guess that's why you actually need to actually go back and substitute it into this equation. So we're going to, maybe I shouldn't have gone in that, but let me just rub that out. No, it's not going to work. No, there we go. So I actually need to figure out what f of 4 is. So if I figure out what f of 4 is, then it's going to give me my maximum. Now, remember I got that equation? So it's negative x cubed. So it's going to be negative 4 cubed plus 6 times 4 squared plus 5. And when I do this in the calculator, where is my calculator? I've got negative 4 to the power of 3 plus 6 times 4 squared plus 5. I've got 37. All right. So at this point, I can actually say local max is 437. So grades wise, guys, f of x found is achieved, or f dash of x equals to 0 and x equals to, so when you find this isn't achieved, but merit is that final grade. All right, let's go to the next question. So what we have is we've got find values of x for which the graph of the function is increasing. Okay, so the first step we're going to do is we're going to actually differentiate. So when we differentiate this function, we are going to get 2/3 multiplied by 3x squared plus 9 over 2 times 2x. We got minus 5x. So minus 5x differentiates to minus 5. And we're going to stop at that. Simplifying this, we're going to get, well, the 2 3's cancel out. So you've got 2x squared, 2's cancel out, and you've got 9x minus 5. All right, guys. Now, if you've been following some of my older videos, you would actually know what we're actually doing here. But let me just show you guys how to do this. There's lots of ways of doing this, and I'm going to try and show you one quick way of doing this because it's a beautiful question in terms of getting one of the easiest excellence. So what we're trying to figure out is when is this function actually increasing? So in other words, when you say when a function is increasing, it's just another code word of saying when is f dash of x bigger than 0. All right, so we've done that. We've actually calculated f dash of x. So all we got to do is we got to figure out 2x squared plus 9x minus 5. When is it greater than 0? All right. Now, whether you like it or not, you actually have to draw this as a graph because that'll make sense. So I'm going to show you guys how to do this. So go into the graphics calculator, click on menu, go into graph, and then just type in this function. So you've got 2x squared plus 9x minus 5. And we're going to press on draw. So what you have is a quadratic right now. Okay, you have a quadratic, and I also need what the two roots are. So I'm just going to click on gsolve, and I'm going to click on root here. So as you can see, the first root is at -5 and 0, and then you've got the second root is at 0.5 and 0. Okay, I hope you guys can see those two roots there. At least the graphics calculator should be showing it. Once you get that, those 2 points, remember those 2 points, x equals -5 and x equals 0.5. So I'm going to go back here, and I'm going to write down somewhere that x is equal to -5 and 0.5. Okay, but that's not the answer though. Okay, this is just roots. So I might even go along and say something like roots for 2x squared plus 9x minus 5 equals to 0 is this thing. Okay, so the next step, what you do is you have a look at the coefficient of x squared. The coefficient of x squared in this case is a +2. You're dealing with a parabola. If you're dealing with a parabola, and I think because in the graphics calculator as well, you saw the shape of the parabola, it looked like this. All right, and you had 2 points. The first point is right there, which is -5, and the second point is here, which is 0.5. Now, the question is asking when is the gradient actually positive? And if you look at it, it's positive before -5 and after 0.5. So that means the way you write up the answer is everything before -5 and everything after positive 5. All right, guys. Those are the two zones where it's actually increasing, where the gradient is actually increasing. Okay, I hope that made sense. If it doesn't, please watch some of the previous level 1 questions. I think there are some in the 2018 prep playlist for you guys to have a look at, because this is it. This is for an excellence right there. Okay, because in terms of merit is this part right here, finding the roots. Achieved is derivative found and made more than 0 or equated to 0. So basically you've got to differentiate it and either put it greater than 0 or putting it to equal to 0. All right, let's go to the next question. Oh, that's fun. All right, guys. So what we have here is one of these optimization questions, or whatever you want to call it. We've got to actually try and figure out what the maximum area of this parallelogram can be. So just to give you guys a bit of a heads up, so we've got 10 at the base there. All right, so we've got 10 centimeters here, and then we've got X centimeters here. So the first thing I'm going to do is I'm going to write down what this distance DG is, which is going to be 10 minus X. And likewise, it's going to be the same thing on the opposite end, where, you know, you've got this distance here from here to here going to be 10. And then because you've got X there, this distance, E to B, is also going to be 10 minus X. So you actually got two triangles where the height is X and then the base is 10 minus X. As for the second triangle, it kind of works the same way. You've actually got 8 that's going across here. Oh, that's a terrible. I'm not going to get this right because it's, there you go. That's 8 right there. All right, that's 8. And then we've got X centimeters here and X centimeters here, which means this distance that is here. Whoa. There we go. Let's try that again. Sorry, guys. Just technical errors. So this distance F to C is going to be 8 minus X. And also A to H is also going to be 8 minus X. So if you think about it like this, what we're going to do is we are going to create a big rectangle, which is this one here. So that's the big rectangle. And that's easy because 10 times 8 base times height, that's 80. So I'm going to take area of the rectangle, all right, and I'm going to subtract 2 of those. Let's see, I'm just going to put these coloring here so you can kind of see it. So that's going to be one triangle. Those two triangles are the same, all right. So I'm going to subtract 2 of those yellow triangles, and then I'm going to subtract 2 of the other triangles, which are the, I'm going to put them as blue here. So these are the 2 blue triangles. Okay, I hope that made sense, guys. Just to get the area of the parallelogram, because if I want area of the parallelogram, I got to take the rectangle minus the 2 triangles and minus the 2 blue triangles. So area of rectangle is straightforward because that's like 10 times 8, so that's going to be 80 centimeters squared. Minus 2 times area of the yellow rectangles, the triangles. So area of triangle is half times base times height. So I'm going to have half times base times height minus 2 times another half times base times height. So I've got 80, take away 2 times half is just 1. So if I look at the yellow triangle, what's the base? That's the X. What's the height? 8 minus X. All right. And then I've got, again, minus 2 times half is just 1. I look at the blue triangle, the base is 10 minus X multiplied by X, which is its height. Now, just so you want to see it in terms of the color notifications, I hope you guys can see it. That's where that X comes from. And then the 10 minus X is the blue part. For the yellow triangle, I've actually got X colored this one. Yeah, so what we next need to do is expand the quadratic, or whatever we get, 80 minus 8x plus x squared, and then you've got minus 10x plus x squared. Okay, putting it all together, we're going to get area of the parallelogram is 80 minus 18x plus 2x squared. Okay, so that's the area that we have, So let's write that down again. Area is equal to 80 minus 18x plus 2x squared. So when I differentiate this, that's the area of the parallelogram. So when I differentiate this, I'm going to get negative 18 plus 4x. Now, for the minimum area of the... Wait, what do we got here? Yeah, so smallest area. So for minimum area, the gradient is going to equal 0. So if the gradient is equal to 0, then I can put this as 0 equals 4x minus 18. And then I've got 18. When I rearrange it to the other side is positive. It's 4x. And then 18 over 4 equals x, which means I get x is equal to 4.5. Now, they're asking you one more thing here, and that's this thing. Justify that your answer is minimum. Now, for those of you that have actually done, there's two ways you can do this. For those of you that have done double differentiation, you could just do that straight away. So if you know double differentiation, then you can just go a double dash is equal to positive 4. And because a double dash is greater than 0, therefore it is minimum. Well, that's a lot of mess there. That's one thing. The other thing you could do is you could actually say, well, a dash is a parabola, is an, sorry, not a dash. A. The formula for area is a positive parabola. All right. And if you think about it, positive parabola actually looks like this, which means it's going to have a minimum. That's another way you can actually explain it. But one other thing that we need to keep in mind, guys, is that we haven't actually found the smallest possible area at all for the parallelogram. So we actually got to do that. So I'm going to actually go back and find what that is. Area is equal to 80 minus 18x plus 2x squared was the formula for the parallelogram. And we know that it's at 4.5 is what x is. And so we kind of need to actually work out what that maximum area is. Really doesn't want to play today. Where is my calculator? All right, let's try that again. So we've got 80, take away 18, multiplied by 4.5, plus 2 times 4.5 squared. So we actually get a 39.5 as our smallest area possible. So grades wise, that last part is actually important to get excellence. This gets you a merit. Expression consistently differentiated. So even if you get the wrong expression but you do it correctly, the differentiated part, you could get an achieved. All right, guys, let's go to question 2. So this is going to be a weird question because it's just the way I can't actually, I just don't have the screen space to work here, but I'm going to try my best to do this. All right. So what we have is graph of the function is shown below, and we've got to sketch the graph of the gradient function. One thing that I'd say is, like, I've seen this done so many ways. I always say this, you know, looking at this is a parabola. It's an x squared parabola. It's a minus x squared parabola because it's upside down. Okay. That means when you differentiate it, your shape somehow needs to look like this, negative 2x, which means it's going to be a straight line and it's going to be facing down. So the only thing that really needs to matter is, this is going to be fun to try and do, is the turning point. If I can line it up. So right now the turning point is there. And if I just kind of drag it all the way down, sorry guys, that's the best I can do. That's where your turning point is, because that's where the gradient is 0. So which means as long as you get a slope of negative 2, wrong pen, and I wouldn't do this. I wouldn't sketch if I were you guys. I'd actually draw a straight line. All right, so it has to be a straight line. It's just, I'm just being, oh no, wait, I can't actually do this. Where's my straight line? Do I have a straight line? Yeah, I do. So something like that. But it's got to, this is the problem. because it doesn't go through. No, see, I'm sorry guys, but I think you guys can't actually see what I'm trying to do here. It's basically one straight line. All right, just make sure it actually goes through that -1. So that's going to be an achieved. All right, nice and easy to work with. So let's go to the next question. All right, so the next question, what we have is a skyrocket is blah, 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 projected. It's given its height. What's the maximum height? So we've got the function of height, and we're trying to figure out what the maximum height is. So we got to differentiate it. So h dash of t is going to be 39.2 minus 4.9 times 2t. So we've got 39.2 minus 9.8t. And we just got to figure out when it's equal to 0, because that's when the maximum happens. So we kind of need to write that down somewhere, all right? So max height when h dash of t equals to 0. So 0 is equal to 39.2 minus 9.8t. Rearranging it, we're going to get 9.8t is equal to 39.2, and t is equal to 39.2 divided by 9.8. So that means t is equal to 4 seconds. But remember, this question is actually asking us what is the maximum height. So you got to go back and actually figure out what h of 4 is. So we're going to get 39.2 times 4 minus 4.9, and it's going to be 4 squared. And when we actually chuck this in the calculator, my calculator decides to work with me and not be a pain. 39.2 times 4 plus, minus 4.9 times 4 squared, 78.4. So that is the maximum height it can actually reach. So grades wise, this gets you a merit. Achieved is actually this part. Just differentiating is not enough. You actually have to differentiate and actually put it equal to 0. Okay, next question. We got a drone. It's moving in a straight line after passing a tree, blah blah blah. Acceleration is given. 2 seconds after the drone has passed the tree, its velocity is 20 seconds. Now, this is important because what I'm going to do is I'm actually do this. I'm going to put down v of 2. So that means velocity after 2 seconds is actually equal to 20. And then if I look at the question, how far was the drone from the tree when its velocity was 20 meters per second? Okay, so I'm trying to actually figure out what the distance it was. So let's have a look at the question. I've got acceleration first. So acceleration is right now 6 minus 12t. So when I integrate this, I'm going to get the velocity function, which is going to be 6t minus 12t squared over 2, which is, of course, I've got to remember that plus c. All right, plus c. The plus c is always important there. So then what we have is we've got 6t minus 6t squared plus c. Now this is the velocity function. So we can actually use this as a clue to try and figure out what that c is. So I'm going to have velocity of 2 is equal to 20, which means I can replace them, and I've got 20 equals 6 times 2 minus 6 times 2 squared plus c. So you got 20 equals 12 minus 6 times 4 is 24 plus c. And I've got 20 equals negative 12 plus c, and then kind of carrying on here, I've got 20 plus 12 equals c, so 32 equals c, which means velocity function is 6t minus 6t squared plus 32. But the question is actually asking for how far was the drone. So I'm actually looking for the s. In other words, I'm actually looking for s of 2, because I know that when the velocity was 20 meters per second, 2 seconds had actually passed by. So I'm going to go and work that out first. So let's see, I'm going to move it here. Hopefully the space is enough. So I've got v of t is equal to 6t minus 6t squared plus 32. So when I integrate this, which is going to be s of t, I'm going to get 6t squared over 2 minus 6t to the power of 3 over 3 plus 32t and plus, it's going to be another constant. I don't know, maybe I'll call it k this time, for example. So S of t equals 3t squared minus 2t cubed plus 32t plus k. But remember, this drone actually is, you're trying to measure the distance of from when it left the, what we got? It's moving in a straight line. How far was it from the tree? So we can kind of assume that when t is equal to 0, that initial distance is actually equal to 0, which means we can actually say, if I put S of 0 equals 3 times 0 squared minus 2 times 0 cubed. I don't think I need to do this, because look, if t is equal to 0 and k is equal to 0, then we can actually say S of t equals 3t squared minus 2t cubed plus 32t. Now we're looking for S of 2, because after 2 seconds, what's the distance? So this is going to be, we've got 3 times 2 squared minus 2 times 2 cubed plus 32 times 2. And when we do this, I'm just going to pull out the calculator. We've got 3 times 2 squared minus 2 times 2 to the power of 3 plus 32 times 2. We actually end up getting 60 meters. So that is our final answer. So let's have a look at the grades wise distance in context when velocity is 20 is found. So that is going to be an excellence. Evidence of distance equation found. So getting up to here, sadly, only gets you guys up to a merit, just to this equation. Velocity equation found is an achieved. So I probably would say velocity equation. I'm not sure whether they're talking about achieved for either here or achieved for here. I'm not sure, guys. Sorry. I would think that it's actually for this part, but you never know what these guys do with NZQA things. Okay, so let's go to the next question. Another one of these diagram questions. So in this case, we've actually been given f dash of x. So f dash of x is, looking at it straight away, you can kind of see that it's actually a quadratic, which means if I integrate this, I'm going to get some sort of weird cubic. All right. So the only thing you need to remember is that this 2 points are crucial. So I'm kind of going to take a, did I line this up right? No, I didn't line this up right. Give me a second. I'm just going to line it up and come back. Okay, let's try this one now. So basically what we're going to do is we're going to kind of line it up there, and just keep going. And then the second point is this one here. Oh man, whoops. This is what happens when you actually paste like 2 separate pictures on top of each other with different sizes. But anyway, you kind of get, I think in your exam paper it'll be a lot more easier. And then the other one I'm going to draw is this pink one here, which is where it's actually changing. There we go. So we know that this is going to be a cubic shape, all right, which means your final answer is going to look something like this. All right, and so that's basically what you got to do. All right, but the only thing is there's an extra bit of clue here, because in this question it actually tells you, I need a different color, the function actually passes through 0, 3, which means this point right here, gotta choose a different color. As long as the graph goes through that point, it's really important, and it's got to match with the roots as well. So in other words, and that's the thing, guys, you don't know what this graph could actually look like, but I mean, like, let me just show you a couple of examples what it could look like. It could have a maximum here, all right, because that's a maximum, goes through that point, and then at this purple point it kind of starts shifting. Okay, that's a terrible one, but let's try that again. Could go like this, and then it kind of turns up and it goes like that. So that could be one example. A second example could look like this, for example. You know, it could go like this, and then come like this, go through that point, and I'm kind of going all the way down like that as well. So I guess what you guys need to realize is that the shape is correct and it goes through that 0, 3, because that's what gets you a merit here. A merit here is that it makes sure you go through the red point here and the shape actually looks like this to get a merit. Achieved is just drawing the cubic as it is. All right, let's go to question E. So what we've got is we've got a graph of this function and it's been told that we've got a turning point at x equals to 3. And we got to try and figure out both turning points, and then we also got to try and figure out what each turning point is. So it's quite a bit of a handful, but believe me, it's not too bad. I mean, we can actually work through one at a time. Because what do we have? We have a gradient. We've got an equation, and we know that it has a turning point at x equals to 3. That means we know that f dash of 3 is equal to 0. Okay, so f of x right now is equal to x cubed minus 6x squared plus kx minus 5. I got to figure out what the k is first before I carry on with this. So that's what I'm going to do here. I'm going to differentiate it. So when I differentiate it, I end up getting 3x squared minus 12x plus k. All right. And of course, I now know that because the gradient function, when it's x equals to 3, the gradient is equal to 0. So that's what I'm going to do. I'm going to replace 0 and I'm going to put the 3 inside. So I'm going to get 0 is equal to 3 times 3 squared minus 12 times 3 plus k. Okay, so when I do this, I've lost my, there we go, come back. So I've got 0 is equal to 3 times 3 squared, which is 27, minus 12 times 3, which is 36, plus k. So 0 is equal to negative 9 plus k. So k is equal to positive 9. So the next one, turning points, fine. So we've got this. Then we actually know what the gradient function is now. So the gradient function is f dash of x. So I'm just looking at it from here to here, but I'm going to replace it with k. So I've got 3x squared minus 12x plus 9. And remember, we're trying to figure out what the turning points are. And looking at this, we want to know when is f dash of x is equal to 0. So I'm going to put that down. 0 is equal to 3x squared minus 12x plus 9. Now at this point, you can go directly to the graphics calculator and get 2 of your points. You know, put it in the quadratic equation formula and get the 2 values. Or you can just be like me and do the old-fashioned way, which is x squared minus 4x plus 3. Factorize it. You're going to get x minus 3 and x minus 1. Therefore, x is equal to 3 or positive 1. So at this point, we actually need to figure out what the respective points are. In other words, we know when x equals to 3 and when x equals to 1, there are turning points, but we also need the y values for it. So what we got to do is we got to do a little bit more work, guys, and I'm going to have to kind of move along here. So what do we have here? We know that f of x is equal to x cubed minus 6x squared plus 9x minus 5. That's what we know. And we need to figure out what f of 3 is and what f of 1 is. So I'm going to do f of 3 first. So f of 3 is 3 cubed minus 6 times 3 squared plus 9 times 3 minus 5, which actually ends up giving me negative 5. But let me just double check that. So I've got 3 to the power of 3 minus 6 times 3 squared plus 9 times 3 minus 5. Cool, minus 5. So my first point is going to be 3, negative 5. And then my second point, which is the f of 1. So f of 1 is equal to 1 cubed minus 6 times 1 squared plus 9 times 1 minus 5. So I got 1 minus 6 plus 9 minus 5, which actually gives me negative 1. So this point is 1, negative 1. So let's go back to the question. We've actually figured out what the turning points are, but we actually need to find out what the nature of each turning point is. So you got a couple of ways to do this. All right, the first thing is this. I'm sorry guys, kind of going all over the place here. This graph right here, it's a cubic. So it looks like It looks like this. And we've got 2 points right now. So this point here is going to be 1, negative 1. And this point here is going to be 3, negative 5. Now you might be wondering, how the hell did I know that? Well, you think about it. This is the x values right here. This is x and this is x. So out of 1 and 3, which one comes first? Well, we know that 1 and negative 1 comes first, so that's why that's going to be the maximum. So you can actually draw this and just kind of write down here, this is going to be maximum, and then this one here is going to be minimum. All right. So you can actually just state it with like a diagram like this. But if you want to get a little bit more complicated, for those of you guys that have actually done double differentiation, and if you're doing calculus next year, it's extremely useful, is actually differentiate your f of x one more time. So that's, we've got 3x squared minus 12x plus 9. And if I double differentiate, I get 6x minus 12. And then if I put f double dash of 1, I get 6 times 1 minus 12, which is equal to negative 6. And then you can say, because f double dash of 1 is less than 0, therefore it is a maximum. And f double dash of 3 equals 6 times 3 minus 12, which is 18 minus 12, which equals to 6. And f double dash of 3 is greater than 0, therefore it is a minimum. So this is something you can definitely use, guys, and that gets you a grade of excellence where you actually have to show which one is maximum and minimum. And as for merit, if you get up to, where is it, up to here, you can potentially get a merit, but you got to find k as well. You got to find k and the 2 values, and then if you differentiate and put it equal to 0, which is about here, you get an achieved. All right, let's go to the next question. All right, guys, let's go to question 3. So question 3, we have a gradient function, which is already given, and it says the curve passes through 1, 7. So I'm going to write this as f of 1 equals 7, and we got to figure out what the equation for y is. So we got to integrate this function, so which means we can write it down as f dash of x equals negative 5x4 plus 6, which means f of x is equal to negative 5x to the power of 5 over 5 plus 6x plus c. So we've got f of x is equal to negative x to the power of 5 plus 6x plus c. And now we know that f of 1 is equal to 7. I'm going to carry on here. So I can write this as 7 is equal to negative 1 to the power of 5 plus 6 times 1 plus c. So 7 is equal to negative 1 plus 6 plus c. Rearranging this, we're going to get 7 is equal to 5 plus c. Therefore, c is equal to 2. So the equation is y is equal to negative x to the power of 5 plus 6x plus 2. All right, so that gets you an achieved. Let's go to the next question. Okay, so next question we have, okay, so we've got some function here. How many days will it take for the rate of change of the number of traders to be 14,400 per day? So what we have is we've got n of t, which is the function. All right, and what the question's asking is the rate of change. Remember how we did this before? So it's asking for the rate of change of the number of traders to be 14,400 per day. So in other words, dn over dt equals 14,400, and they want to know what is t. So that means we got to differentiate n of t. So we know that n of t is equal to, let me just put it here, n of t equals to 1,000 plus 400t plus 100t squared, which means dn dt. You can still use n dash of t if you want, it doesn't really matter. You're going to end up with 400 plus 2 times 100 is 200t. So basically, we've got this equation, 400 plus 200t equals 14,400. So rearranging this, we're going to get 200t equals 14,400 minus 400, and 200t is equal to 14,000, and of course t is equal to 14,000 divided by 200, and so ends up being that t is equal to 70 days. So another achieved question here, and then we go on to the next question, which is, here we go. All right, so what we have with this particular question is we've got, oh sorry guys, this is just messy today. Yeah, apologies about the tech breaking down today a little bit. It's all right, we'll just keep carrying on. Okay, so what we have is we've got a school that's selling tickets. The revenue is given by this formula. Use calculus to find maximum possible revenue. So guys, straightforward question in terms of calculus. Differentiate, equal to 0, and solve. So what we have is R of P. We kind of need to expand it first. So 40 times 29 is 1160P minus 80P squared. Once you get that, we need to differentiate it. So R dash of P is equal to 1160 minus 160P. And we want to know when it's the maximum revenue. So we can actually say the max revenue, R of P is equal to 0 for max revenue. So we can actually say 0 is equal to 1160 minus 160P. Rearranging it, we are going to get 160P equals 1160, and then P is equal to 1160 divided by 160, which means P is equal to 7.25. All right, so but just remember one more thing. This question is asking us what, and use calculus to find the maximum possible revenue. What you've just found is what the price of the ticket should be to get the maximum revenue, which means we actually got to go back and actually put it into R to actually find out what the maximum revenue is. So in other words, we got to go R of 7.25 equals 40 times 7.25 multiplied by 29 minus 2 times 7.25. Let's just hope I'm right on this, but let's try it out. So we got 40 times 7.25 times, what do we got, bracket 29 minus 2 times 7.25. And we get a maximum revenue of $4,205. Grades wise, guys, this is what gets you a merit. Find RPN equals to 0 gets you an achieved. So that's right there. Okay, that's question C. We go to question D, which is the last question. And it's one of those weird questions where you get 2 T's for it. But let's have a look at it, how to do this. All right, guys, last question here. I do apologize if the sound sounds different. Just had some technical difficulties, but hopefully we're back in the game. So the last question for this particular exam paper, what we have is we've got tangent to this graph, and it's at some certain point P, has a gradient of -7 and intersects the graph again at -664. So what I tend to do is like just draw a rough sketch of this graph here, because this graph, if you look at it, it's a cubic graph and it's negative, which means we're going to have a graph that looks something like this. It's not the best diagram, but hopefully you get the idea. And we've also got two, what do you call it? Well, there could be 2 points where it has a gradient of -7. So you could have a gradient of -7 somewhere here, or it could be like this. All right, and I know it's not the best picture, but I just want you guys to picture what it looks like. And then it again intersects the graph again at -664. Okay, so first thing to realize is that there's actually 2 points where you're going to have a gradient of -7, and only one of those tangents is actually going to touch negative 664. So what is the first thing we're going to do? The first thing we got to do is try and figure out what k is. Okay, and the way we're going to do it is, we know that the graph actually goes through the point negative 664. So that's the first step we're going to do. So we know that f of negative 6 is equal to 64. We also know that f of x is the function that's highlighted in yellow. So we've got negative 1/3 x cubed plus kx plus 4. So substituting our values, we get 64 is equal to negative 1/3 negative 6 to the power of 3 plus k times negative 6 plus 4. So what we then have is, I'm going to need my calculator. So first things first, what do we have here? Negative 1/3. So negative 1/3 multiplied by negative 6 to the power of 3. So that's equal to 72. So I've got 64 equals 72 minus 6k plus 4. All right, so rearranging this, I've got 64 equals 76 minus 6k, and then 64 take away 76 is equal to negative 6k. So I've got negative 12 equals negative 6k, and I can say k is equal to negative 12 divided by negative 6, which then equals to 2. So I've got the equation. Now I want to know at what's the x value for the, or what's the x value when the gradient is equal to negative 7. So, but to do that, I actually need a gradient function. So let's go back to the f of x first. So f of x is equal to negative 1/3 x cubed. We just figured out what k is, so that's going to be 2x plus 4. And when I differentiate it, I'm going to get negative 1/3 multiplied by 3x squared plus 2. Simplifying it, I'm going to get f dash of x is equal to negative x squared plus 2. So what I want to know is, what are all the x values when the gradient is equal to negative 7? So I want to know when is the gradient equal to negative 7. So I'm going to go to negative 7 equals negative x squared plus 2. And if I rearrange this, I actually end up getting, what have we got? I'm going to bring the x squared to this side, so it's going to become positive. And I'm going to take the 7 to the other side, which is the left-hand side. It's going to be positive as well. And leave 2 where it is. So what I've got is x squared is equal to 9. Therefore, I can say that x is equal to plus or minus 3. So once I got x is equal to plus or minus 3, my next step is to actually work out what those y values are, the respective y values. So I'm going to move along here a little bit. So what I need to do is, so basically think about it as like this. You know how I said that there's actually going to be 2 points where the gradient is going to be 7? So what we've just discovered is one of the values is negative 3 and the other value is positive 3. So we need to get the two y values for it. And so that's what we're going to do right now. So once again, we know that the function is equal to negative 1/3 x cubed plus 2x plus 4. And we want to know what is, when is it x equals to 3 and when x equals to negative 3. So when x equals to 3, we've got f of 3. So that's going to be negative 1/3 multiplied by 3 cubed plus 2 times 3 plus 4. So when I do this, I've got negative 9 plus 6 plus 4, which equals to positive 1. So my first point is going to be 3, 1. And as for my second one, we've got f dash of negative 3. It's going to move a little bit here, folks, which is going to end up being negative 1/3 multiplied by negative 3 cubed plus 2 times negative 3 plus 4. And when I do this, negative 3 cubed, so it's going to be a positive number, 3 squared, so it's going to be 9 minus 6 plus 4, which equals to 7. So my second point here is going to be minus 3, positive 7. Okay, so at this point, what am I actually trying to figure out? I'm trying to figure out the coordinates of point P. So I've got those two values, right? 3, 1 and negative 3, 7. So this is what it looks like, 3, 1 and negative 3, 7. I want to know which one of these green lines here, the green lines, is actually going to go and touch at negative 6, 64. Okay, so you can kind of have a look at this graph and straight away see that, you know, like if you look at the black line is going to go somewhere there. So I'm guessing by the looks of it, negative 6, 64 is somewhere going to be here, which means the tangent that's on 3 and 1 is probably going to work out. But we've got to actually prove it. So how are we going to prove it? The way we're going to prove it is actually work out the equations of the tangents. Okay, so we know the gradient of both of these tangents is at minus 7. So I'm going to work out for the first one, which is 3 and 1, I'm going to put down as y equals mx plus c. And of course, I got to do it in the other one as well. So I'm going to get y equals to mx plus c. So what do I got? I've got 3, 1 as my point. So that's going to be 1 and 3. And the gradient is minus 7. So when I do this, I'm going to get minus 21 plus c. Rearrange this. I'm going to get c is equal to 22. So the equation that I have for this particular point is going to be that y is equal to negative 7x plus 22. And then for the minus 3 and positive 7, I've got to do the same step. So 7 is equal to, gradient is minus 7 times minus 3 plus c. I'm going to get 7 is equal to 21 plus c. So c is equal to minus 14. So the equation for this one is y equals negative 7x minus 14. So now I need to check which one of these two lines is going to have the point 664, negative 664. Okay, so let's try in the first point here. So I'm going to go y is equal to negative 7 multiplied by negative 6 plus 22. And that's equal to 42 plus 22. So y is equal to 64. So this one works out. But in this case, y equals minus 7 times minus 6 minus 14. So you're going to get y is equal to 42 minus 14, which equals to 28. And of course, this one doesn't work out. So straight away, we can see that the point 3, 1 is actually the correct answer. So you kind of need to write a little sentence somewhere, I would say. So I would write, like, you know, once you finish all the calculations is, actually don't have space. Use calculus to find the coordinates of point P. I would probably just write it, sorry guys, I'd just say 3, 1 is the P where tangent touches graph at negative 664. Okay, that's basically how we do it. In terms of the grades, this is one of those weird ones again where you get like 2 excellence grades or like 2 t values, which means you end up getting like 8 points for this question. So you could get 1E for just kind of getting to the 3, 1 correct point of 3, 1 found, and validity and clearly correctly justified. So you got to justify it to get that second E point. For merit, you can, for getting a value of k found gets you a merit, and you got to find derivative. So to get a merit, you've actually got to find value of k found and derivative found. So that's going to be somewhere here. Is that, yep, and set equal to negative 7. So you got to do all of these 3 things to get merit. For achieved, finds derivative and sets equal to negative 7, getting a quadratic. So you could potentially get an achieved for this, doing this step. Or you might even get an achieved for something here where you actually do some of these straight line parts. you could potentially get and achieved as well. Alright guys, I know that was a very, very tedious question, but you know, that's what it is. So with that, I just want to say thank you very much for actually making this far to the video. And if you have any questions or comments, guys, just pop it in the comment section below. As always, don't forget to like this video and subscribe to the channel. And of course, the other thing that you could do is just share this video with your peers. Alright, one last thing, as always, good luck for your exams. And yeah, make sure you guys actually answer every question and don't leave anything empty. Alright guys, thank you for watching.